Okay, Math 30s, welcome to Friday's lesson, Simplifying Rational Expressions. We're just building on what we did Wednesday with non-permissible values, restricted values, yesterday with equivalent forms of rational expressions. Now what we're going to do is simplify rational expressions. So what we're doing is learning to write them in simplest form. So what you need to be able to do after today's lesson, or after practicing the questions, is simplify a rational expression, explain why the non-permissible values of a given rational expression and its simplified form are the same, and identifying correct errors in a given simplification of a rational expression. That should be rationale expression, and explain the reasoning. So writing a rational expression in simplest form. A rational expression is in simplest form when the numerator and denominator have no factors in common other than 1. So this is when the numerator and the denominator, numerator remembers the top of the fraction or rational expression, and denominator, that's the bottom, have no factors in common other than 1. Okay, and all that we're going to do is a few examples here. Okay, so we're just going to do 3 examples, and that's it, and then you have some text work to do. So we're going to express the following rational expressions in simplest form and state the non-permissible values as restrictions. Do your non-permissible values first. Those have to come first. So for this one, 2x equals 0, which means x cannot equal 0. Now in simplified form, we look at what's the biggest thing that we can divide out of the top and the bottom. We can divide out 2x, divide out 2x. So 12x squared divided by 2x gives me 6x, and then that's over 1, so that's just 6x. Non-permissible values first. So a plus 7 equals 0, so a cannot equal negative 7, and a plus 1 equals 0, so a cannot equal negative 1. Okay. And then we look at what's common. So we have an a plus 1 in the top and an a plus 1 in the bottom. So we're going to cancel those out, and then this can just be written as a minus 6 divided by a plus 7. And you can write this way: a cannot equal negative 7 or negative 1. Or you can just leave it the way that we did here. Leave it like this. Okay, 8y plus 2 divided by 8y. So 8y equals 0, so that means y cannot equal 0. And we're going to divide out 2. So divide everything by 2. So we get 4y plus 1 over 4y. And that's as simple as we can get with that one. Okay, this is a difference of squares. Okay, and so we have to write it out as in its factored form first. We're going to have 7 minus x times 7 plus x. Okay, so that means 7 minus x cannot equal 0. So x cannot equal 7. And 7 plus x cannot equal 0, so x cannot equal negative 7. And then if we look at this, the factors we have in common here are x plus 7 and x plus 7. So this becomes 1 over 7 minus x. And you can write this as x cannot equal positive or negative 7 if you want to simplify that. Okay, E is looking a little bit annoying. So what we want to do is let's actually kind of factor out as many of the p's as possible first. So we can factor out a 2 out of everything and at least 1 p. So 2p, this becomes 6p minus 4 divided by 2p times 3p squared minus 2p. Oh, actually on the bottom, let's take out a p squared. We can take out a p squared. So 2p squared, and then we get 3p minus 2, like that. So in terms of non-permissible values, just looking at the denominator, okay, so just looking at this right away before we simplify anything, 2p squared cannot equal 0, so p cannot equal 0. And 3p minus 2 cannot equal 0, so 3p cannot equal 2, so P cannot equal 2 over 3. If we simplify this now, I can actually simplify the top a little more. I took out a 2p, but I can take out 4p. So let me actually just rewrite that. 4p, which gives me 3p minus 2, like that. Okay, now look at, I have these in common. I can get rid of the 3p minus 2. I can get rid of 1p. And I can get rid of a 2. So I'm going to write this as 2 over p. Okay, we'll do the restrictions here first. T plus 3 cannot equal 0, so t cannot equal negative 3, and t minus 5 cannot equal 0, so t cannot equal 5. So now what we want to do here is, if we look at the top, I can factor out a 3. So this becomes 3 times t squared minus 25 over t plus 3 times t minus 5. I can factor this some more. 3 times t minus 5 times t plus 5, because t squared minus 25 is a difference of squares. And that's divided by t plus 3 times t minus 5. And the t minus 5's cancel. So you're left with 3 times t plus 5 divided by t plus 3. And that's as simple as it can get. Okay. Next example. Using a common factor of negative 1. So you can use, sometimes you can use this. What this does, like if you multiply by negative 1, it changes the place of the negative number. And this is best illustrated by an example. So what I mean by that is if I take out a negative 1, okay? So I'm going to leave this as well, first of all, 4 minus c equals 0. So 4 cannot equal c. Okay, so that's our non-permissible value. I'm going to leave the top as it is, c minus 4. What I'm going to factor out of the bottom is negative 1. So when I factor out a negative 1, what that does is it changes the sign on everything. So negative 1, so that gives me negative 4, because 4 divided by negative 1 is negative 4. Negative c divided by negative 1 is positive c. And I can rewrite that as c minus 4 divided by negative 1 times c minus 4. So these cancel, the c minus 4's cancel, and actually what you get as an answer there is negative 1, is how that one simplifies. Okay, so what can we take out of the top? We can take out a 2p squared, so we're left with p minus 2. And on the bottom, we can take out an 8. So 8, and we're left with 2 minus 2p. So what we're, 2 minus p. What we want to try and do here, actually, if I take out a negative 8, let me take out a negative 8. So I'll take out negative 8, so then I'm left with negative 2 plus p, okay, which I can rewrite as 2p squared times p minus 2 divided by negative 8 times p minus 2. Okay, and my non-permissible value here, p minus 2 cannot equal 0, so p cannot equal 0, cannot equal 2, p cannot equal 2. And if I look then at what I can cancel, I can get rid of my p minus 2's, so then I'm left with 2p squared over negative 8, and I can cancel out 2's, so I have p squared over negative 4, and that one is simplified. Okay, so last example. The area in square meters of a rectangular plot can be represented by the expression x plus 6 squared. And the length in meters of the plot can be represented by x squared minus 36. So we want to write and simplify a rational expression that represents the width of the plot. So what we have here is that area equals x plus 6 squared, and length equals x squared minus 36. which we can write as x minus 6 times x plus 6. Okay. Oops, plus 6, not 2. Okay, area is length times width, and we want to solve for width. So width is going to be area divided by length, which is x plus 6 squared. So it's x plus 6 times x plus 6 divided by x minus 6 times x plus 6. So we're going to simplify that. Okay, so we can write and simplify the expression. The non-permissible values here, x minus 6 cannot equal 0, so x cannot equal 6. X plus 6 cannot equal 0, so x cannot equal negative 6. And then we're going to simplify. That cancels, and we're left with x plus 6 over x minus 6. If the length of the plot is 28 meters, determine the value of x if x is greater than 0. So the length of the plot is 26 meters. So what we have then is x squared minus 36 equals 28. So x squared equals, see, 36 plus 28 is 64. So the square root of that, if we square root both sides, x would have to equal 8 meters there. Okay. X is greater than 0. So you can get 64 by going negative 8 times negative 8 or 8 times 8. But we reject the negative 8. The plot has to be treated with fertilizer at a cost of 2.40 per square meter. Calculate the cost of the treatment. Okay, so we're saying here that x equals 8. Okay, and area is x plus 6 squared. So that's 8 plus 6 squared, which is 14 squared, which is 196. So then the cost, so it's 196 square meters. The cost is going to be $2.40 for every meter, and there's 196 square meters for every square meter. So that gives us a cost of $470.40. Okay, so your assignment for today, again, is from the textbook, page 229 to 231, numbers 1 to 9 and 13. And keep in mind, you guys, that I'll go over any trouble that you're having with this on Monday. So we'll spend some time on Monday kind of reviewing what you learned on the video lessons and seeing if there's any trouble on that. And have a good weekend.